Okay, so this is your Edpuzzle homework. I'm just gonna go kind of over class today. I'm doing this in the morning, so we have class this afternoon. But I'm doing this morning, and I'm not sure how far we're gonna get through the lesson today. We may go even farther, and this may be review, or this may be brand new, depending on how much we get through today's lesson. So the main topic that we're going to teach you today, let me turn the slide on. This idea of a GCF is almost like a thing you need to know before we get into doing the more challenging factoring of trinomials. GCF, greatest common factor. So you're going to take out stuff from your parentheses. So hopefully we kind of covered it, but if we didn't, if I was to say 2x plus 4, and that's your parenthesis, and you're writing this all down. You're using your notebook because you're going to have to do multiple problems with the Edpuzzle. I'm deciding if I want you to post it or not. So you write these down, okay? And you got to pull something out of this. You got to take something out of it. You're basically dividing something out. And what is your result going to be? And if you notice both terms, what do they have in common? That's the kicker. You got to figure out what do both terms have in common and what is the greatest thing they have in common. And if you could see, they both have a 2 in common. Both terms have a 2. So I can divide a 2 out. If I was to divide a 2 out, think of that idea. If I was to divide a 2 out and I take a 2 out, what's left? 2 out of 2x, that's just going to be 1x or just x. And then 2 out of 4 is a positive 2. So this just got greatest common factor got pulled out of this. So does this actually become the same answer? If I was to dolphin jump again, would I get this? Or dolphin distribute property, if I was to distribute right now, would I get the same answer? I would. If I was to distribute, I would still get 2x plus 4. Okay. Understanding this method today is going to help you when we solve the more challenging trinomials that I have for you. So you're still going to be doing the same idea of X games, our diamond problems, whatever you want to look at it, okay, where it's A times C on the top and B on the bottom, okay? And whatever multiplies to equal the top, whatever adds to equal the bottom. And I do like doing that little symbol here. Okay. All right, let's try a problem. This method, this idea. Okay, let's just actually do one more practice run with this. What if I had 8x plus 12? Now, what would that turn into? What could I divide out of this? Well, 2 goes into both, but that's not the greatest common factor. If you were to take 2, then you would have, 4x plus 6, and then you could take 2 out again. If you notice that 4 goes out, you could take 4 out. So 4 is going to come out. And what's left? 2x plus 3. All right? What if I did it even more intently? What if I said 8x squared plus 12x? Now the parentheses have changed a little bit. We have variables. This is to the second power. This has an x. Guess what? You can still pull out an x too. So 4, not x2, but you can still pull out an x also. So look what I did now. I'm dividing out an x. What's left? If I take a 4x out of 8x squared, what's left? 2x. And think about it. What's 4x times 2x? 8x squared. That's a great way to check your work if you did it properly. Now, if I take 4x out of 12x, okay? This is a concept for some reason messes with honor students. I've noticed in the past. You just got to think you're pulling something or ripping it out. You're dividing it out. You're breaking it out. And then you're giving me something simpler in the parentheses. Okay? That's something to know for this method. So today's method, we're going to call it the trash can method. They actually teach this in high school, in their high school algebra classes. And what's going to happen eventually is what at the end, your answer may have this part going in the trash can. All right, those are your big trash cans. The lid. And what's going to happen? Your final answer, you're going to trash this this number at the very end, and we'll talk about it. But I'm just trying to give you a method. We're going to trash can method this, and you're going to be like, what are you talking about, Marusik? Stay with me. You'll get there. Stay with me. Okay, so let me give you a decent one to start with. 1 second. All right, so your first problem is going to be 5n squared plus 19n plus 12. Okay, so what's different about this today is that your coefficient a is greater than 1. Okay, so a is greater than 1. I want you to think about this problem in the same way, though. You're still going to do the same method. A times c is on the top, b is on the bottom. So let's go ahead and go for it right now. A times c is on the top, okay? So a times c, 12 times 5. 12 times 5 is 60. B goes on the bottom, 19. All right, now we're doing the same method. We're trying to figure out what multiplies to equal 60 and what adds to equal 19. What multiplies to equal 60 and adds to 19? We're going to have 15 and 4. Okay, so this was the first step. And just doing this part's the first step. Second step, you must now, I'm going to write this down here. This is your notes, basically, so I would write this down. Write parentheses for answer, except use a, your coefficient a, use a to start the answer. Okay? Now, this looks confusing. Write parentheses for answer, except use a to start each parenthesis or start answer. No, the grammar doesn't sound good there. I'm doing this on the fly, but I want you to think about your parentheses here of what you're going to have. So when you start your parenthesis, you're going to start with this 5n. This 5n is everything. Not the squared, but the 5n. 5n goes here, 5n goes here. Before, yesterday, remember, or Tuesday's class, we would have n as the parentheses. So n would be the parenthesis. Then you would have this to be here. All right, so now, hold on 1 second here. Okay, so again, write your answer in this 5n. They both have to start with 5n here. This method seems a little different, a little weird, but just know it works. It does. So 5n and 5n, and then now you use these two factors. These two, we're going to eventually call them roots, and just put those as your answer. Okay? So that's your final answer, right? But this is where I'm telling you this method comes into play, the GCF. So your last step, let's go ahead and write our parentheses out. 5n plus 15. Let's go ahead and write our answers again. But now you're going to have to go ahead and get rid of these. Let me just autofocus here. It's kind of bothering me. All right, so now you're going to have to get any GCF. GCF when needed. Look at both of them and see if they need a GCF. Do you need a GCF this? There's nothing you can pull out of this. So that is for sure done. This is an answer. That's an answer. We call these factors. That's a factor, okay? But what about this one? Can't I take out a 5? It's pretty easy to see. 5 goes into both of these. So what's left? N plus 3, okay? 5 is out, n plus 3 is in. And guess what your final answer is? This is the fun part. This is where the trash can comes in. Trash the factor. Trash the GCF. Trash it. Whatever you pulled out, trash it. So this is now going in the trash. It's no longer needed. Okay? So your trash can method, your final answer is going to be n plus 3, 5n plus 4. Those are both factors that are going to work. Okay? I know it seems a little odd, but literally, I'm not lying. I've been into math classrooms. I've observed high school math classrooms, and this method is still existing, that they're able to do this, and it's consistent. It works. It works for these trinomals each time. As long as you GCF at the end, you're good to go. Okay? Trust it. Let's go. All right, let's do one where you go on your own. Again, you're using your pad, your work. All right, let's see what you guys can do. Now, 2x squared plus 3x minus 9. Go ahead and try to factor this out. Figure out what's going to work here. You guys do this on your own. Try to get to an answer even, if you can. All right, 9 and negative 2, negative 18. Positive 3 on the bottom, okay? What multiplies and adds, okay? What multiplies to negative 18? Adds a 3. Pretty easy. You can see 6 and 3. Positive 6, negative 3. Okay, positive 6, negative 3. Great. Now, let's move on to our final step here. We're going to have to start our parentheses. What are we going to start them with? Not 2x squared, just the 2x, okay? So 2x starts both our parentheses. You must start that with that coefficient. This coefficient a is important to be part of your factor. It may get trashed eventually, but to start your factoring, you must do that. Now, 2x plus 6, 2x minus 3. Okay. Can we do anything with this one right here? We can take a 2 out here. All right, so that's going to be x plus 3. Can we do anything here? Nope. So your final answer, remember, is going to be this and this. We are trashing this guy. So x plus 3, 2x minus 3. All right, final answer on that one. Okay, let's do another one. Let's keep it going. I want to see how you guys are doing. 3x squared minus 8x plus 4. Go for it. Let's get to a final answer for me. Let's see if you can pull this off. All right, now this one's a little tricky. Negative 6, negative 2, right? Multiplies to positive 12, adds to negative 8. Then what? 3x, 3x. Both my parentheses start with that. Remember that. Don't forget that. Always is going to start with that coefficient. 3x and 3x. 3x minus 6, 3x minus 2. You're going to start to be able to do this pretty quickly. You're going to start to see it pretty quickly. That 3 goes into both of these. So it's going to be x minus 2. If you're not sure, you just go ahead and distribute and see if you get your answer. If I distribute, I get 3x minus 6. That's what I got, okay? And then 3x minus 2, there's nothing you can pull out from that. What goes in the trash? This guy. These are both factors. So there may be a question that says, like, which one of these is a factor, like A, B, C, or D? Like and then say, which one of these answers is a factor? And you might see like 3x minus 2, x plus 4, x minus 5, x plus 7. And it would be this one. Just because both are not in there in your answer pool, it doesn't have to be. If it said select all that are factors, right? And then like E was the final answer there too, then it was x minus 2, then you would select all. But sometimes these questions only ask for like one of these, just tell me one of the factors. And it's kind of interesting, all right? Alrighty, let's do one more. Let's see, okay. I'm trying to give you a challenging one. All right, this one's kind of crazy because it goes into the idea that I hopefully covered today in class. Again, I'm thinking I'm doing all this before class, so I'm prepared. But sometimes, like, I don't prepare out weeks in advance my lessons because things change as I'm teaching lessons. Things change often. So I have to make sure I keep up exactly where you guys are. So I kind of do it day by day, week by week is what I kind of go by. So let's go ahead and solve this. Now, this is crazy. Aren't these numbers pretty big? When you see trinomials with these big numbers, you can do something with them. You can break them down into smaller parts by a GCF, right? Now, this part's kind of weird. So when you do this part, hopefully in class today I showed you, if you can pull something out of this, and if you notice 3 is a common factor, the greatest common factor of all of these, all right? So 3 into that's going to be what? 3K. How can we double check our work? If we multiply this, would we get that? Sure. 3 into 66, what's that going to be? 3 into 66 is going to be 22, right? And then what is it? 3 into 21, we know that's going to be 7. All right, we just pulled a 3 out. This, if you did this before you even started X Games, this does not go into the trash. You leave this on the outside. And it's weird. I've seen problems where they have it on the outside for multiple choices, and then sometimes some books haven't had that on the outside, but it's weird. You can GCF this to start. Don't even worry about it. Now, this will be part of your final answer. We're going to keep that for later, but we are going to do the X Games of what's inside. 7 times 3 is 21. 22 is on the bottom. Well, that's pretty easy to see, right? What's 21 and 22? 7 times 3 is the only factor. No. 7 times 3, there's one more. 21 times 1. Don't forget that 1 is a factor as well, all right? 21 times 1. Does that work? 21 times 1 is 21. 21 plus 1 is 22. It sure does. And then how are you going to start your parenthesis? With that one. 3K. 3K. Okay. Now you have 3K plus 21. 3K plus 1. Correct? So when you get your final answer, we're almost done. Let's go ahead. We know this one can't be factored anymore, but this guy sure can. Can we take a 3 out? And we're going to get K plus 7. Okay? K plus 7, remember, in our method today that we learned, this goes in the trash can. Not this one. I know it's the same number, but you when you GCF, when you get your final answer after X Games, that's when you throw something in the trash. So I have K plus 7, 3K plus 1. Let me write that little even. But don't forget, when you do GCF something out of it, it has to come down and chill and be part of that answer. All right. Hopefully this was helpful. Hopefully you did well with this. I'm not going to see you till next Tuesday. Have a great weekend. Hopefully, again, that you got something out of this, writing it down. I will talk to you later.